Hey, Evan.
Hey Drew, good morning. Oh man, I thought it'd be
Good-
light attendance, but I didn't expect just two of us.
Really? I guess. Oh, yeah, it's 7:04.
Yeah, I was a few minutes late.
Well, maybe I'd like to show you kind of some things I'm thinking with analysis and see if it makes sense to you. And maybe we can just keep it a short meeting.
Yeah, sounds good.
All right, let me
Yeah, and
pull.
I'll take a note to kind of I don't know what everybody's doing over the holidays, but I haven't heard anything back on the formatting stuff we presented last time. Um,
Yeah,
Only notice I got about it is that Hank from CT requested access.
and there's a guy named Gus White at Microsoft that I asked to review it.
Okay.
I don't know if he requested access or not, or maybe I gave it to him.
Yeah, um I didn't see his access request come through, but I'll keep a lookout and see if he needs access. Yeah, I
Sounds good.
guess I've got a conflict here at the bottom of the hour too, Drew. I forgot about, so
No, we
best
can
to have
keep.
a short one for me anyway.
Yeah, it works for me. I'm not one to complain about that.
I'm hoping this continues to be a bit of a light week as we get closer to kind of a holiday break here.
Oh, at HP, it became Ghost Week.
I've got a friend at HP here in Boise, and that sounds like what's still going on.
Well, what happened was everyone gets to the end of the year and they have use it or lose it vacation. So,
Yep.
it's the right thing. It's use it. But then Google and to some degree at Microsoft, there's this end of the year rush to get your end of the year objectives done. So,
Oh,
and we don't lose vacation. So people are just working,
yeah. I
pretty
guess
steady.
all of our Micron objectives and stuff are on the fiscal year, and we've got a weird fiscal year. Ends in it ends September 1st.
Oh,
So I
wow.
kind
Yeah.
of like that. Our end of year rush there happens in August. So our end of calendar year is a little slower. Hey
The only,
Neil.
the only problem with that is it lines up with back to school. It's like, man,
Mm-hmm.
wow, August sounds rough.
Yep.
Hey, good morning, guys.
Hey, Neil.
So you
So,
take
oh, go ahead.
I was just gonna ask if you're taking the weeks off, Drew.
Yeah,
You gonna be working? Yeah.
I'll be. Well, you know, I'm fairly new to Microsoft, so normally I'd be worried about vacation, but they have a unlimited vacation policy, and I mean, and then of course they're encouraging folks to take the holiday week off because that's a great time to do it. Everyone's, it's like I'm not going to
Yeah.
be right. Um,
Yeah, exactly.
so yeah, I'm going to be doing that, but yeah.
Cool.
So we're going to go visit my mom in North Carolina, so I'm looking forward to that.
Awesome. Hope you have a good trip.
Thanks. You have anything planned?
I'll be around town. My wife's family is in Boise here. We'll be around town this year. So
Oh, that's
nothing
not.
huge. We'll be over there for the holiday, but it'd be nice to not travel.
Yeah, yeah. And it's nice to have the time off at home where I can get projects done. So,
Hmm. Yeah,
um,
that's kind of what I'm thinking too. But yeah,
cool. Hey, Yun. So I think we'll have a short meeting. I was just going to catch uh, Evan up and whoever wants to listen on some things I'm thinking about analysis. And the reason I'm mentioning it is I'm starting to, like I mentioned this in the hardware fault management team last week, and I got a surprising number of questions about it. And I'm realizing that, these things that we've been talking about here, and I think are obvious now, aren't as obvious to everyone else who hasn't been here. And that's really that's legitimate, right? We need to explain some of this stuff better. But so what happened last week was I showed some of the analysis overview stuff, and we're proposing a new thing. We're proposing a CPAL, a Common Platform Action Log. And so, Anil, this is relevant to the conversation you and I had where we really wish the analyzer output was standard. And so the CPAL would be like a CPER, but you can send it's a format that lines up with the CPER creator ID. So and in a way that if you have 8 GPUs in a machine, you can line the CPAL up. You can say, I got a CPER from this GPU, and if I'm going to send a RAS action back to the machine, I send it back to the BMC, and the header of the CPAL matches the header of the CPER, and the BMC can, with little effort, send it to the right device. But it's also going to be partially like standard. There'll be fields in it. So like if Intel has a special memory reliability feature, they can have that, and maybe they'll say, here's the feature I'm using with a name so we can filter on it, but then they'll have a command that they pass back to their platform to activate the feature. And when I described all that, um, people were like, wait, what's this time series thing? And so I wanted to walk through how I think it's going to work with you all, because we're the furthest along in thinking about time series, even though I think I'm saying that even for crash dumps, let's say we have a crash dump where a system dies and has a fatal error, I may use previous seepers from that machine to give me hints about what caused the crash dump. The crash dump should be hermetic in that when the machine failed and stopped running code, I captured everything I could that would help me figure that out. But there might have been past errors. And just as an example, one reason we have crash dumps is because we have uncorrected memory errors. If you have an uncorrected memory error while you're handling an uncorrected memory error, that's a nested thing. And most CPUs will go, I can't run code. I'm getting nested errors while I'm handling the error. And they die, and then you crash dump. And so if I saw a series of corrected memory errors and I saw an uncorrected memory error, that's a really strong signal. It strengthens my argument, if I'm making one, that yes, indeed, the memory problem caused this particular crash dump. And so, that was kind of my argument. And it was kind of an epiphany to folks that, wait, we could do time series for all sorts of things? And I'm like, yeah, wherever you need to. And so then Tanya Sadak at Intel was like, how does that work? Because she thought it was really complicated. And this is what I want to run over with you. I think it's pretty simple. I think what happens is we get a new error log. We get it all the way to this CPER bundle block. We've previously asked the analyzer how much error data it wants. So we go back in time and get any CPERs. We don't even think about what they are. It's just, are these CPERs from the same machine? And then send that bundle to the time series analyzer. The time series analyzer will look at the newest CPER, and it could be that, there's a problem in the mesh inside the chip. And that's completely self-contained in the chip, and it's obviously a chip problem. And it may not need time series data. So, it may not use the time series data in that case. It'll just go, you've got a bad chip, replace this chip. In other cases, it might say, wait a minute, that was a memory error. I want to look at the pattern and see what I can infer from the pattern. And at that point, the time series analyzer looks back through the CPER bundles and finds memory errors. Maybe it has to decode all of them, but then when it gets a memory error, it looks at that and says, oh, it's a memory error. Okay, where was the error? And builds the pattern, and then it runs ML in the pattern or whatever. So does that align with what you all are thinking?
Drew, I'm a little bit trying to catch up here. I think initially you were talking about CPAL,
Yeah.
and now you're describing time series.
Yeah, well, I was giving you the
I'm
context for why time series came up, but we have a doc, Anil, where we're tying them together because people weren't keeping up with what we were doing here because we weren't communicating it back. But CPAL was basically VLOS's response to your problem of needing a standard analysis output.
Mhm. Yeah, so time series concept is not new, right?
Oh, no, I mean, Superdomes do it, right? It's ancient.
Yeah, we do it in our fleet all the time. I mean, we have to do it. There's no other choice, right? Because every machine is spewing a lot of information and with the different attributes. And we have to analyze when we are looking into any specific fault pattern or a generic fault pattern time series all the time.
Absolutely. And so all I'm doing here, Neil, is saying that for these analyzers, so let's say that I get an analyzer from Intel. What I do not want is a crash dump analyzer, a corrected error analyzer, uncorrected error analyzer, and have to run them all over, a whole bunch of places. What I really want is one stream of seepers that goes from corrected errors to crash dumps. And let's say we're using scan on the fly that triggers under certain conditions. I even want to wrap that in a seeper so the same collector collects it. And the analyzer may go, hold on, this is that special unlocked, debug file. Um, I can't necessarily analyze this, but here it is. Send this back to Intel, and that's fine. But we want one stream, all the logs one place, and we can analyze any of them in time series. Is really what I'm arguing.
Yeah, I think one difference I would clarify, at least in our experience in Meta, my experience, we have two sort of objectives. One is based on the event information generated by a machine, how quickly we can make a remediation decision. Okay. And the second use case or the path is let's continue to collect the data and perform the post-processing like a dashboard and some actions from there, which is a slow path. So we have kind of fast path and a slow path. The time series is actively used today in the slow path because it by nature is a slow process to keep collecting data and then do some additional post processing and then take an action, or maybe don't take any action, just dashboarding.
Oh, but
Whereas
yeah, I've thought of that, and I think that you better be careful because if you drain a machine the first time you have a corrected memory error, then that's obviously wrong, right? I mean, you wouldn't do that. But if you drain the machine because the analyzer said, "Hey, I've seen some memory errors, you're at risk of crashing," that's exactly where we're doing the fast path predictions in most other companies. Is on the time.
our fast path mostly is triggered through some uncorrected errors. Now we do have the prediction based on correctable errors also, which is also fast path, which is fairly conservative. And there we don't really collect like a time series. Being a fast path, right? We just look at the previous data and the current data, and then compute whatever the matrix, error rate, error velocity, and then take an
Yeah.
action.
Well,
Right.
but like look at chip kill ECC. So when we designed that back in the early days, we designed it and used double chip kill even to give us this was when I was in my previous job. We designed all of this with the intent that we had order months to respond to the typical memory failure. And the reason was that it took a while to send a service person out, and we wanted the machine to continue to run for the customer while that happened. So with corrected memory errors, if you have decent ECC, maybe we don't have months, but we have time. And so collecting a few of them to build a pattern usually works. Doing it
Yeah,
all
no,
one
yeah.
or
I mean,
two.
timing wise is, sorry to interrupt you. Timing wise is fine. I think the challenge is when we are implementing at scale, fast path, we don't have the going back in the time storage as well as we want to keep that very simple, very fast action, like a more of a combinatorial kind of flow. That okay,
Right.
if you see,
But here, I'll go back to our previous conversation, Anil. If I had the FM analyzer that accurately predicts crashes, like really accurately predicts them, why would I reinvent that algorithm? Why wouldn't, I mean, is the fact that the analyzer took 100 milliseconds to run rather than your fast path 25 milliseconds going to deter you from using it?
yeah. So if the analyzer, the FM, right, is acting on the current data, um, memory, in some sense, memoryless flow. Memory errors for a memoryless with implementing a memoryless flow.
Stateless. We call it stateless.
Stateless. Thank you. Right. Then it's okay. I mean, we still don't want to keep it simple and not rely on the vendor code. But if we have to do it, that is still doable. I think what I'm trying to differentiate is that this time series concept, at least in our fleet, right, is more applicable where we are looking at the aggregated data either on the same machine or across the machines.
Oh yeah, no. The whole point of FM, Anil, is to have the memory vendors recognize what's failed in their DRAM and describe the scope of that failure to the CPU vendors so they can predict how well their CPU ECC is handling it and do things like predict crashes. So so that's fine, but what we're doing here in FM is not across the fleet; it is per machine,
Yeah,
and it's supposed to be something you would effectively run in the fastpath because you're predicting crashes.
right. And we don't need time series for that, do we?
Yes, you do. You absolutely do.
Tell me
And
more about it.
look at superdomes. That's exactly what superdomes do, and that's how they get their memory reliability. Is they look at what they do. What they do is they identify the type of error and then they count them and then predict that, oh, this is bad. I'm going to trigger an action, and that's exactly what we're doing here as well. You like I, at a previous job, we drove ADDC without time series, and we knew that our reliability was going to be kind of crappy, or not our reliability, our accuracy. And so yeah, I don't think that like what I'm talking about for this kind of prediction uh, is pretty much universally done with a series of errors because
Actually, so you're giving a good example of A3DC, right? I'll just give you a example of a machine that we debugged fairly recently, where we have implemented it, and we were told, hey, this machine is slowing down, something is going wrong, and our application is getting impacted. Okay, so we looked at it, and I did find, as you was pointing out, right, a time series, and I saw that 2 days ago on that machine there was a bank failure or bank AVLS, virtual happened. Okay, and machine survived, continued to operate without any issue actually. But then 2 days later, there was a rank level failure, rank level VLS. And right after that, the application impact happened. And the problem was that our remediation, which was fast path, had some problem that the rank failure. So bank failure, we actually tolerated. We didn't trigger any action. But the rank failure,
Oh,
it
wait,
should have.
wait, were you using ACCC on the
Yeah,
bank?
yeah. So bank virtual lock strap, machine survive, very small impact. Rank failure, the next event happened. Basically, there was a device. The whole device was crappy. One of the DRAM device. And so it started with the bank level, and after some time, after roughly 2 days, additional banks start failing, and therefore it went through this whole reverse bank sparing and then rank sparing and all that flow.
Yeah, let me walk you through how that would work if this infrastructure was in place, because this is a perfect example of why we want to do exactly that.
Let me finish it. Okay.
But
Okay.
but I can already okay. I see your problem, but I can tell you. Go ahead. I already understand, and I already know. But go ahead.
Right. So by looking at the previous day, 2 days worth of time series data, right, I was able to understand manually that what exactly happened here. Our problem was that our remediation based on the rank sparing did not trigger, because that should have been triggered. Now that actually doesn't require time series, because that's as soon as the rank sparing happened, there is an event. The event is logged. Machine actually has generated a cell log or CPR log saying there is a rank level virtual lock strap happened, and that should have triggered a immediate remediation, drain the machine, because now there's a risk of some performance impact.
Yeah, I understand, and
So
let me. You've done
summarize.
something wrong though in this example.
Let me summarize. So what I'm trying to communicate here is that the fast path action really did not require time series, but
it did. You don't
let
let me. You already understand. You did something wrong. You drove ACCC in the platform. That is the problem. So the whole point of this infrastructure is to make it easy to drive RAS actions, and that what happens today is that people don't understand how ACCC works. They use it under the wrong conditions, and they have these hand-built solutions. And so the whole point of this is to do the time series analysis in the analyzer, say, hey, ACCC would be a great solution here, and send that back to the machine. And when you do that, you would get a CPAL back to the machine, and that CPAL, when your infrastructure got it, might say, oh, when I get this, I know this machine performance is toast. I'm also going to drain this machine and send it out for repairs.
No, that we would not know, because the application impact is downstream. Like, how would we make that correlation? That's
because you know that when you go into this mode, the performance is impacted, and all we have to do.
No,
is
I don't know. My remediation flow, right? The tooling doesn't know that it's too late. By the time application impact happens, too late. Then prediction is useless, right? I need to predict before the application gets.
I think you don't understand. The time series analyzer needs time series to drive ACCC correctly, and I helped design ACCC, so I really understand it.
And I implemented it, so I also understand it.
No, Intel's default implementation had some mistakes in it, but we didn't care because we had it right in SuperDump. But there were some actual problems in but we needed time series data to drive it correctly, and so the whole point is that when you specify a RAS action back to the platform. So let's say that I bought an Intel chip made a server, and I don't know the first thing about ACCC, but I sent the memory seepers through this infrastructure in a time series format. The analyzer gets it. And then it says, okay, you've got a rank problem, or we'll start with a bank problem. Let's trigger ACCC. We send the message back to the machine, the CPOL, but we do it through this. So the analyzer analyzes the error. We get, I call it CPRA here, but it's CPOL is what we're calling it now. We evaluate the accuracy of the output. If there are multiple errors, we reconcile them from the different analyzers, and then we have policies to protect our fleet. And the policy might be that if it's a workload, like a cloud workload, and I'm using a feature that says it has a performance impact, I drive a repair action rather than send the RAS action back to the machine. So what I'm talking about works, and we really should be driving ACCC off time series data.
Drew, you said you have implemented this in Superdome, right?
Mm-hmm.
What kind of latency you get?
I'm sorry, what was the question?
What kind of response time you get?
Pretty quick, but it's a small microcontroller. You don't have to. So this, do you need like millisecond response? I don't think so, but if you have order minutes response, you're fine.
The performance impact, I'm talking about in microseconds. Otherwise, it's too late.
I don't know of a single cloud workload out there that I've ever experienced where I need to do something in milliseconds.
I mean, that's how the action need to happen at the machine level. Like virtual lockstep need to happen trigger. Of course, it takes time to finish it, but the trigger need to happen.
No, it doesn't. You have time.
I don't understand.
That's a mistake.
I disagree.
So the way that ECC is designed, if you have chip kill ECC, it's probably one chip that has a problem. So now you have to say, well, what are the odds of a second error occurring in another code word during this time frame? And with a single chip, you have generally order months before you expect a soft error in a chip.
I just gave you an example. I mean, right? It just took 2 days, and once we get to the second bank failure event, right at that time, the action needed.
Oh, I think what you're thinking is I have to wait 90 days to do the analysis, but you're doing the analysis with every.
No, not 90 days. Not 90 days. And what I'm saying is that as soon as I detect my failure is actionable, okay? Detection, the action need to taken. I can't wait for analysis done 10 minutes, 20 minutes, whatever time it takes. I don't know how much time it will take to finish this, this loop, and then trigger an action.
But wait, were you saying because what is causing the perform? Are you worried? So there are two performance degradations. There's the retry from the corrected error, and then there's the invocation of the virtual lockstep that also slows things down, perhaps even more.
Yeah, there are multiple SMIs happens, but that's after we trigger the event.
Yeah, but in this case, there are no SMIs. It's all out of band logging or in band logging, but there are no SMIs whatsoever. You got an error, and the only penalty on the machine for the error is the retry.
Yeah. By the way, I'm puzzled. Actually, you're saying that you implemented on a Intel platform without SMI.
I am saying, oh, the only SMI needed, okay, is I have to be careful. So there's the future and there's the past. So the way it was implemented on Superdome, they had SMIs for errors, but you didn't have to. If you did in-band error logging, the only SMI you need is the one to trigger virtual lockstep. You can log the errors without SMI. All right, you can just have an in-band collector. People do that all. You do that. I mean, right? Rasdeen.
Yeah, but we didn't invest it on because Intel didn't provide a lot of things here, so we relied on threshold-based SMI.
Yeah, well, that's not a problem with this infrastructure. That doesn't argue against.
And that was not a problem. It's the threshold base, so it was not that fast. But anyway, the point I'm trying to make here, Drew, is if you're trying to implement this with this like collecting data, then post-process it as a time series, and then decide an action somewhere in the infrastructure, and then send a message to the machine. I don't know if anybody has implemented it and what kind of results we are getting. I need to see the data. Like, intuitively, it doesn't make sense to me.
So the what this is baffling to me, Anil, because the places I've worked all have AI crash predictors. So this is what I'm like really puzzled. I mean, I'm kind of shocked that you think this, because this is like everything we're doing in FMFM.
I'm talking about taking the ADDC action, right? Analysis part, I get it. Time series makes sense. And then as a result of that, some action if required.
Well,
and that could be ADDC also, and I'm not saying no. Of course, there's no infrastructure today that I know of that Intel has provided to send an in-band message to trigger ADDC.
Oh, no. Yeah, I agree. Well, you'd have to trigger SMI today.
Yeah. Right.
But the thing that we're talking about in this infrastructure is doing it out of band. And Superdomes, the analysis engine drives this, and it's another little machine in the rack. It's not on board. So it's a micro implementation of this. And they look at the pattern. They don't look at an individual error to drive by IEEE.
Yeah, I mean the pattern, is either a threshold event or there has to be some pattern, but that is all within the machine itself. What I'm puzzled here is that you're driving this thought process to pull the data out from the machine and then do a post-processing in real time.
Yeah.
And then send back the message to trigger the event.
It's really simple, though. Every time you get a new error, you just analyze that error and the previous data you got. And it doesn't take that long. It's not that complicated of an analysis.
Complexity is not the issue. The thing is that the latency, the return path, it has to be local as possible. And you're driving a completely opposite direction that I think of. And that's why I'm kind of puzzled.
Why does it have to be as local as possible?
Because it's a fast path. Intuitively, in the control theory, right? If you want to take a fast action, you have to be the closed loop should be so close, as simple and close as possible.
I don't think that's so. Like let's go back to ADDC.
Mm-hmm.
You have chip kill, and so then the only way you're going to get an uncorrected error out of that is either you get really, really unlucky and a soft error strikes another DRAM on the DIMM, or you have a channel signal integrity problem that affects multiple DRAMs. I guess you could have just bad DRAM, but the odds of them failing within days of each other are infinitesimal. So everything about error rate modeling and fit rates indicates with chip kill ECC, because you can tolerate the failures from apart, that you have time. And that's what I've measured. I've looked at this, and when you have corrected errors before an uncorrected error, um, you have time. Like we studied it. You do have time to do something like this. And even if it takes order 10 minutes, you're okay, because um, the odds of a part failure in that time window are so low.
Yeah, I mean, the certain film modes I can understand. It's a slow process, and there's enough time there.
Well,
Therefore, slow path may work, right?
I mean,
Uh,
HP, Dell, Lenovo, they all pushed. I mean, like and IBM, everyone that was looking deep into reliability designed reliability such that they had, you know, they had time. They designed and spend money on transistors so that they have time to react to problems. The only hard real-time problem in fault management that I'm aware of is that if you have poison recovery and you want to analyze poison recovery, then that analyzing poison recovery in order to say you've recovered from poison a few times, but you should really give up.
mhm.
That's the only hard real-time problem, because you have to do the analysis and you can't hold the OS up for it. And
Right.
so the way to solve that problem is just to say, if that could just be counted. That's the way to get the fast path for that. Just say I've done too high a rate of recoveries. I must be stuck. I'm going to go down. But
Yeah.
but other than that, all the other RAS features, they're designed such that you have time. Now, containment is different. Containment has to be instant. It has to be like nanosecond. It has to be as the error is discovered. But containment is hardware automated. It's in the hardware. We don't have to. We need to react to containment, and but reacting to containment is slower. It is contained by the hardware, by crashing or by doing something, and now, oh, the link is down. Okay, let's DPC triggered, let's bring the link back up. And that can be done on software scale timeframes again.
Yeah. Um, anyway, in my mind, Drew, intuitively, right? Because I don't know what kind of fault is going to happen. I have to kind of make a assumption that I need both path, fast and slow. Okay, and
Yeah.
fast path need to happen within the machine itself. I don't have the liberty to go all the way out and then come back.
Then you're gonna then run the analyzer on the machine.
Yeah.
But my point is, it's still an analyzer. It's still time series data.
Does it?
Yeah. So we
Yeah.
won't. And as far as I'm concerned, I've done this enough times that I'm fine.
Once again, I thought analyzer, what we are discussing and defining here, right, is based on the error data for that event that we collected. Isn't true?
No, it's a time series.
Interesting.
The whole point of FMFM, like literally the entire point of this group, is to do accurate memory analysis.
Then where is the
And
syndrome information used for then? Because I thought syndrome information is critical to make that and the part of the analysis to make a decision.
Yeah, it's in the list of things we're collecting for DDR5. It's there.
Yeah, I thought that an analysis part is you get a CPR, you see the pattern. If the pattern looks more complex than a single bit,
No,
then
okay.
take
When I say pattern, I mean pattern over time,
pattern over time.
as opposed to a threshold. Counting errors, we always contrast pattern detection with thresholding. And so thresholding is counting memory errors. And that's where you get the 0.6% precision. It's like you're just better off flipping a coin than counting memory errors. So what we do is we look for patterns. And we say the first error had this row address. The second error, look at that, it had the same row address. Third error, same row address, maybe a different column. And now you go, oh, okay, main word line driver or sub word line driver, depending on the scope of what bits are flipped. Let's do a post package repair. So the analysis results are, hey, you should do a post-package repair. And you go, yep, that analyzer, I believe, There are no other errors, so it's reconciled. And policy to protect the fleet, we haven't done many of those lately. I don't need a rate limit or anything. I believe it. Let's do it. And so we send the CPOL back to the machine and drive the post-package repair. But we did it on time series data.
Yes, but what you describe makes sense. You said 3 events. 3 events were sufficient to make the decision, right?
Yeah.
The first event, you got the address and the syndrome. The second event, oh, it's the same error, same row, or different row, or same row, different pattern, syndrome, right? Third event, same row, maybe same pattern or different pattern, but the same row.
But that's what this analyzer does. That's exactly what we're saying. And now let's say that I continue to have errors because you decided not to do post-package repair.
No, just one second. Let me finish my thought, right? So 3 events, and you got enough data to make the decision, right? I don't call that the time series. I mean, you theoretically, yes, it is time series, but that can
is
be
the time
implemented.
series analysis, Anil. That is exactly a time series analysis. When we say time series analysis, we give you 90 days, but it doesn't take 90 days to get the result. It took however many errors it took to discover a pattern.
Mm-hmm. Yeah, I mean, that is today pretty much implemented within the machine itself, right? I mean, even the SM handler keeps track of the previous either 3 or 4, or I think up to 5 events.
That's a machine, that's a biospecific behavior.
Yeah, I mean, it could be BMC, it could be kernel, right? REST daemon, yeah, but within the machine itself, right?
But the point is here that it could be that, it could be that you had an error 90 days ago in a particular row address. And it might be that the OS then stored something to that address that made it go away and only read from that address, but it stored a 0 to a cell that was stuck at 0, so no error. But then a little later they changed that. You know, well, let's say a month later they change that and we get another error. And then we get another error. The fact
that makes sense, Drew. Sorry to interrupt you again. That makes sense. If there's some behavior that is happening very sporadically, right? Then they're taking the data out, saving it for the past 90 days. Or I think for us, we don't have the capability today.
But we don't want a bunch of different solutions. This solution works for the case when they occur 3 in quick succession, or they occur 3 and 90 days apart. That is exactly the point. We don't want 10 ways to do things. We want one way to do things. And I would argue that it was a corrected error, for crying out loud, and we've only had a handful of them before we acted. And okay, maybe it's a billion if you have a stuck cell that you keep accessing over and over again. But if you were going to crash, you would have crashed. So, you know, don't think that because we're saying we want 90 days of worth of data that it takes 90 days to come up with a conclusion. It may be that you send us 90 days worth of data and there was nothing in there. There was no error. And then suddenly we get our first error. Okay, that was the first, and we look for the pattern. No pattern, it was the first. Then we get the second, the third, and now we start seeing the pattern. So we see the pattern as soon as we see the pattern.
Yeah, so in this example that you just gave, right, the first event and then took like 90 days to get the second event, right? In my mind, these are not really actionable. They're nice data points to observe, store at the time series. I'm fine. I agree. I get that, right? But they're not actionable to me.
You don't know that. So that's actually the entire point of this, is that the memory vendors understand their part. And they may say, oh crap, this is one of those flaky parts. Based on the part serial number range, I'm worried. I'm going to tell them that I'm predicting a crash because I know that this part, when I see this pattern from it, fails. What we're trying to do is let the experts give us an expert opinion about the part that they designed.
Yeah, for that, I think that use case makes sense to pull the data out and store it for prolonged time, and see if there's any known silicon behavior kind of post processing, right? And it won't be a fast path to begin with. It'll
Why
be
not?
more. Hmm?
Why not? Why not? Why not? Because that failure could be rapid onset. It could
No,
be
because it requires a lot more like, working with the vendor, saying, hey, I see this thing. I mean, by nature, this is a very slow path.
no. Watch this, Anil. Imagine that Microsoft figures this out with the memory vendors with a new die route, and we get the weekly version of the new weekly version of the analyzer. We copy that in, roll it out to our fleet, and we prove that it works. Then Intel gives that analyzer to all its customers, and now you learn in your fast path the things that you benefit from the lessons we learned, and we benefit from the lessons you learned in the fast path.
Yeah. So that becomes a trigger that, okay, if you see this pattern, don't wait for 90 days, just trigger
It's just
the
a new
trigger right away.
analyzer that recognizes the trigger. Yeah,
Yeah. So that becomes a fast path. I agree with that. But that doesn't require time series analysis, right?
it
Because
might.
once,
It absolutely might.
hmm, okay. I
The reason I'm saying that, Anil, is that I have seen it needed. Like I can't speak to it because it's a proprietary thing with a particular memory vendor, but I have seen it needed.
hmm.
And the only way we saw it was looking at a huge amount of data. But then once we recognized it, it was pretty simple to encode in an analyzer. In fact, we did.
Exactly. And that becomes a fast path, right? Then you don't need time series again.
But no, it was still looking at time series.
Yeah, for the future one, any something new thing,
No,
right?
no. We recognized a failure pattern from looking at a lot of data. That's global data.
Oh, I see. What you're saying,
That
when you say
pattern,
pattern here, you're saying pattern over a long time.
whenever I say pattern, I mean time series.
Hmm.
Whenever I say pattern, it is always time series. Always. So
Yeah. So
every time I've uttered the word pattern, I've meant time series. So the point here is that we discovered something, and it was a pretty stinking big deal. And they're like, oh crap. And we could build an analyzer, and we would look for this particular pattern over this time. And if we knew it was a certain range of parts, then we're like, it's one of those. It's one of those special parts. We know this is something we got to do something about. And otherwise, it might have been, I might have just shrugged and said, yeah, whatever. I don't care about this.
and that pattern time duration was how much? Like days or months or seconds?
No, I mean, it was however long it took to see enough errors. It
No,
could be, I mean, it could be 5 minutes. It could be 3 months. The thing that's really important to realize is that we are just along for the ride when you use memory, right? We are what we're doing is um, we are watching whatever the OS does. And so they could store values that cover up the error because they store a value that, and they don't mean to, but if you store a 1 to a stuck 1, you're going to get an error. And so you have to look at patterns over time. And over time might be, the next few milliseconds as they access memory. It might be over the next few months. The over time varies. It just depends on whatever the OS decided to do. You have to wait 24 hours for the patrol scrubber to come back
if it is few milliseconds, then how will this scheme work?
because we
Because
will see a stream of seepers from the machine, and you will see those and you'll say, here's the pattern. I'm acting on the pattern and drive an action back. And so maybe we end up seeing the problem for a few minutes, but that's fine. There's nothing that urgent about doing that. And now I've got a clear message about what I'm seeing. And so down here in the policies to protect the fleet, I can say when I see this situation, when I see this analysis result, I know I should probably just turn off this machine and stop using it. Or maybe in this particular, there's some use cases where we've identified workloads where VLS is they're not memory bandwidth limited, And so you can enable VLS and just say, fine, no one's going to know the difference. And that's good. The customer likes that because the customer keeps running and they don't care. Their workload's healthy. They got good data. The machine stays up. So,
Hmm.
you know, the analysis giving you a clear output of what's happening on the machine, and you might get it multiple times. You know, if you don't act on the error, or it might say you have a corrected memory error. This is probably benign, but you could say, you know what? I don't care. It's benign, but I don't like this machine having any memory errors. I'm going to repair the machine. It's going to get expensive for you because you're going to do unnecessary repairs, but you could decide to do that.
Mm-hmm.
But the
Yeah.
point here is that updating firmware is slow. So doing it on the machine is painful. And I can update these analyzers if they run in the cloud on a weekly basis. I mean, one place I worked, we could roll it out in 15 minutes if we
Mm-hmm.
had a new one that we trusted, you know, and of course,
Yeah, I mean that's that benefit of. I mean, we always look into this trade-off, right? There's always a trade-off. More you push out in the infrastructure, it is easier to update, but at the same time, it is a lot more taxing in terms of the storage, because we are talking about, pretty large fleet, right? So there's a balancing act, and how long we want to retain the data, right?
yeah,
Uh,
absolutely.
so.
And what I would suggest is that this analyzer will tell you how much data it wants, and that's the minimum you should store.
Mhm. Yeah, so our strategy is that wherever there's an actionable events that we know a priori, or at least high noisy data, implement the simplistic logic within the machine itself, and then provide that signal to our infrastructure to trigger the action. Uh, and if there are less noisy, ambiguous data, yes, sure. Pull the data out, put in the manifold somewhere, do post-processing, learn from that, and then figure out what the action, then again implement FastPath. And so that's the kind of iterative process we go through that.
Well, my advice to you then would be you may need to run the analyzer in two places. But if you're running the analyzer local to the machine, then storing the previous CPRs is trivial.
Mm-hmm. Yeah, I mean, we do like a handful of previous data points, whatever the storage we can do locally, right?
I mean,
And then take the action on that.
yeah, you should, I mean, you should generally be able to, maybe you say, well, I do 90 days until some buffer overflows, then I throw away the oldest ones.
Yeah.
But this strategy still works. It just, it's going to suck for you because you're going to have to roll the analyzer out to every machine now. But you know, Meta has the same problem, right? Like Pure Storage doesn't have a cloud they're running in. They sell products to customers. And so our plan was to do this at the large scale, get it working, prove the concept works, and then we'll figure out what resources the analyzers take. And it might be that you can put them in the BMC even if you or you could have a rack manager, which is kind of like what Superdome does. They call it a rack manager now, and that's where the analyzer runs for the rack.
Mm-hmm.
So you can be local, it can be remote, but I would argue you're better off having the analyzer running in fewer places and having fewer pipelines. You know, if you can get one
Mm-hmm.
pipeline right, you're way better off. And the I would argue that the output of the analyzer is you decide whether it's urgent or not.
Mm-hmm.
But the beauty of this is that if I decide it's urgent, I decide it right here at policies. I just have a table and I match the CPOLs to something in my table and go, well, that one I know I better get moving on fast. I'm going to, you know, prioritize draining that machine or migrating VMs off the machine. This one, okay, well, we've lamed the machine and it's kind of running a degraded state, but this customer prefers to stay up. I'm going to let them stay up, and I'll schedule a repair, you know, at some time that works for the customer. But
Mm-hmm.
by making these things clear in one place, you have one. Then you have the ability to tune what you want to do for the customer, even within your fleet, because different workloads may have different policies.
Yeah. Cool. I think good discussion. Sorry, I challenge you
I
many
get
places.
hot about this. I'm sorry too. I don't mean to come off as, what were you thinking? But I'm just like, oh crap, we've been talking about patterns and we're not clear on them. But hopefully we are. If we can use the word pattern, always mean time series, or maybe I just never say pattern and say time series pattern. I can do that too. But
Yeah, no, that's a good clarification. I didn't register in my mind when you said pattern, you were talking about the time series pattern. Because pattern could be, syndrome pattern also, right?
it could be. But the problem there is that you just don't know. Like usually it's a single bit, or even if it's multi bits, is it more than one address? So yeah, I
No,
see the
I
confusion.
definitely look at multiple event. That's for sure. And theoretically, it is a time series also, but that is a very short time series.
Well, yeah,
Simply,
that's okay. In fact, what I would argue is that, hey, vendors, um, do your best with as little data as possible. So here's what I would say. For the obvious ones, we want it to be as fast as possible.
right.
With the subtle ones, it can take longer
Yeah.
because we need it to be more accurate. But doing it this way allows us to be fast or take care of the subtle problems.
Yeah, I think that the hang up here, Drew, is that when you make that statement, right, you always kind of give the message that, okay, this is all implemented in the infrastructure, right? And then also you're saying, well, it's up to you. I mean, you can implement locally also, right? And in
Well,
my mind,
that's part of your infrastructure, though, right?
right? Yeah. So I think the difference is how we actually implement it. It would be like two locations based on the use case, fast path, slow path. Theoretically, this block diagram, this flow chart apply to both, and I agree with you.
It does.
Right.
It does, absolutely. And
Yeah.
and this one does too. Um, and that's something that we talked about last Friday is we'll put some text in that the that we're talking about doing this in the cloud now, and there are a lot of advantages to doing that, but that this stuff can happen different places. I mean, it could happen in like if I was HP or Dell, I'd say, hey, I've got this appliance that manages my machines, and if you want warranty service, you'll let me analyze the errors, uh, and here's the appliance, and the appliance, it could be something that is dirt cheap. It could just be basically a little single board computer that costs me $50, and you need, one of these for every so many machines. It could be that you put it in your BMC. It could be that now, if you run it on the OS, you're going to have the problem that you're going to have to run it two places. And you could do that. You could run the analyzer two places, but now your analyzer is getting the fast path stuff locally and the crash dump and debug dump stuff remotely. So you do have to kind of run it off of the host node for crashes.
Yeah, that's true. Yeah. Any kind of uncorrected error, right? We always pull out.
Yeah. Well, maybe a deferred error, which is technically uncorrected, could be done on machine if you're.
Yeah.
But otherwise, yeah. And so that's why I'm saying I don't want to do it two ways. I want to do it one way.
Yeah. No, we want to. Because since we own the whole infrastructure, we want to optimize it, and the right thing is to implement locally and then remotely both places.
So but I guess, do you see the point is now I cannot, well, maybe what you'd have to do if you do that is you still have to send all your corrected errors to the fleet one, like let's say the slow path.
Yeah. We do that. Yeah. That's for now. So we send all the data, right, for post-processing, dashboarding, study, maybe some actions come out from there, or some vendors look at there's a pattern here. I mean, we do all that thing, right? But that's all slow path for us.
But I guess what I'm saying is, like, let's say that I'm thinking strictly per machine.
Yeah, it's per machine. We can massage the data either way, right? But once the data is in a big data what you call lake or whatever, right?
Yeah.
Then we can massage the data per machine, per time window, different type of model, different type of machine, different vendor. I mean, all kind of stuff, right?
Well, but my point here is, okay, so if you do the local thing on the machine, you would get corrected errors to the analyzer, and it would do all of this, and you have this kind of locally. But then you would also need to send the very same errors to get the best results, I think, to the analyzers up in the cloud, because if you have a crash dump, it may want to look at your prior corrected errors. Right?
Yeah. I mean, today we are doing manually, but yeah, down the road, if we can put some automation to converge the two, that'll be good. Yeah.
Yeah, well, that's the dream here, right? Is that I get corrected errors, uncorrected, deferred, I get crash dumps, debug dumps, all out one path, and the analyzer can see the whole history of the machine, and by doing that, draw the most accurate conclusions possible.
Mm-hmm. Yeah. Cool.
So
Yeah.
it sounds like you can do what you want, but I kind of question it. But now go for it. If that's what you need to do, that's what you need to do.
Yeah. Good. So I think let's close today's call.
And by the way, Neil, I'll send you the doc to CPALs, and we should probably talk about it because you and I had this action item to talk about standardizing analyzer output.
Okay.
But you remember you and I talked about, we're like, what you really need is not a standard decoder. We need standard analysis output.
That's
So
right.
we can act on smart things that the analyzer told us.
Yep.
And
And
so,
I'm driving same thing internally also, and so far I'm getting positive signals from my team. Yeah, that's the right thing to do.
cool.
Let's go drive it.
Okay. Well, I'll send you the CPAL proposal, and you and I need to talk and work on that. It was Vilos's suggestion, and I think we still want the decoded JSON for the huge file. But
Mm-hmm.
the point that Vilos made is, yeah, but you also want something that's imminently machine actionable, like you can automate.
Yeah.
And that's the beauty of having something that it looks like a CPER log, but it's but it contains the RAS actions and repair actions in it.
Mm-hmm. Yeah, makes sense. I mean, CPAL is basically almost similar to this our cell logging that we have
Yeah,
implemented in the past, right?
yeah. It just has more of a CPER format. It matches
Right.
like it'll match some of the fields of the CPER that identify like the GUID of the thing that sent it and the creator ID, so that you can match the creator with the thing that you need to send the action to.
Right. Yeah.
Okay, well, good. Well, thanks for bearing with me on that. I know it's a hot argument, but I that's what I like about you, Niels. We can argue and figure it
Yeah,
out.
I'm also learning, right? I mean, this is all learning stuff.
Yeah, and I'm learning too, so this is good. So hope I didn't scare everyone else, but thank you. This was good, and it's good for you and I to get on the same page. I need to catch you up with the stuff that's been going on. So you and I need to talk about some of these other things too.
Are you going out somewhere during this holidays or?
Yeah, I'm around this week, but I'll be gone next week.
Okay,
So
maybe we can put some time together, talk.
yeah, I'll reach out to you.
Okay.
And Charlie, I saw you wanted to talk too. So
Yeah.
do you want to talk one-on-one, or you want to
If you've got others interested, I'd be in the group, but if not, then we can make it a one-on-one. Either way.
Okay, sounds good. All right. Well, thanks everyone.
Thank you.
Okay.
Thanks a lot.
Talk to y'all
Bye.
later.